Okay, welcome to Chapter 15, Section 3 on wave interactions. Let's get right to the key ideas here. How do waves behave when they hit a boundary, when they pass around an edge or opening, and when they pass from one medium to another? What happens when two waves are in the same location? And lastly, how are standing waves formed? So, move right into it here. How do waves behave when they hit a boundary? When they pass around an edge or opening, and when they pass from one medium to another. So when a wave meets a surface or a boundary, the wave bounces back. When a wave passes an edge of an object or passes through an opening, the wave bends. And a wave also bends when it passes from one medium to another at an angle. So reflection. Reflection occurs when a wave meets a boundary. And reflection is the bouncing back of a ray of light, sound, or heat when the ray hits a surface that it does not go through. Some examples: the reflection of light waves in a lake can create a mirror image of a landscape. And water waves are reflected when they hit the side of a boat. So let's watch here a little bit on reflection.
When any kind of wave strikes a surface that doesn't absorb or transmit it, the wave is reflected away from the surface. The reflection of waves off some surfaces may cause the wave to invert and bounce away with opposite phase.
Okay, so at a free end, you saw there the wave gets bounced back just the same as it came on the same side. But if the wave somehow is fixed at the end, it will sometimes invert and go back underneath its rest position. Diffraction is the bending of waves around an edge. So diffraction is a change in the direction of a wave when the wave finds an obstacle or an edge, such as an opening. So an example: water waves diffract around a block in a tank of water. So if you have waves that are going and there's a block or something around it, those waves will bend around that corner and keep moving. Sound waves also passing through a door will diffract. They'll move around the door frame. That's how you can hear people in other rooms. So diffraction waves bend when encountering obstacles or openings with sizes comparable to the wavelength. So let's listen here for a second.
Diffraction. Diffraction is a change in the direction of a wave when the wave encounters an obstacle or an edge, such as an opening.
Okay, so you can see here, here's water going around, the waves going, and you can see how they're starting to bend as they move through. There's a water wave coming, and then it starts to bend, just as this depiction shows you here. Alright, waves can also bend by something called refraction. Refraction is the bending of a wavefront as the wavefront passes between two substances in which the speed of the wave differs. All waves are refracted when they pass from one medium to another, or basically one material to another. Let's look here a little bit as far as light and glass.
Light rays that strike the surface of the water at an angle bend as they travel from air into water. This property of light is called refraction. Refraction of light occurs because light travels as waves. When waves travel from one material to another at an angle, their speed changes and they bend. Light waves, for example, move more quickly through the air than they do through water. A beam of light, therefore, follows a straight path as it moves through the air, bends as it enters the water and changes speed, and then continues on a straight path through the water.
Okay, so we got the refraction of light there. Interference. What happens when two waves are in the same location? When several waves are in the same location, they combine to produce a single new wave that is different from the original waves. This interaction is called interference. And interference basically is just the combination of two or more waves that result in a single wave. Constructive interference increases the amplitude of the wave. So something called a superposition of the two or more waves that produce an intensity equal to the sum of their intensities. Basically, the amplitudes add together to give one major amplitude of the individual waves. Destructive interference decreases the amplitude. So the superposition of those two waves, when they're destructive, they produce a wave that is smaller than the amplitudes of either of the waves. So you got here some depictions of constructive and destructive. We'll start on the top left here. You have two waves in a string that are approaching. You got a large and a small wave pulse, both traveling toward each other. As they meet, their amplitudes combine or add together to form the amplitude for the single wave, and then they continue in their original form after they've interfered. For destructive interference, you have one on either side of its rest position. So you have disturbances on both sides instead of just disturbances on one side here of its rest position. So one's on top and one's on the bottom here. When they meet in the middle, because they destructively interfere, the amplitude is smaller than either one of them, and in this case, if they're equal, it basically cancels out completely. But then the waves do continue to travel on as they move through the medium, which is the rope. So the interference of light waves creates some colorful displays. When two light waves, or two waves of slightly different frequency, interfere with each other, they produce something called beats. So here you have destructive interference occur, constructive interference, and destructive interference. So they're out of phase a little bit. So what happens if you have large amplitudes here, you have very low amplitudes here. So this one thing here is called a beats, where you have this energy goes from small to large back to small again. It's something called a beat. Standing waves. How are standing waves formed? A standing wave causes the medium to vibrate in a stationary pattern that resembles a loop or a series of loops. Standing waves, or standing wave definition, is a pattern of vibration that simulates a wave that is standing still. So standing waves have something called nodes and antinodes. Each loop of a standing wave is separated from the next loop by points that have no vibration. Those are called nodes. And midway between the nodes lie points of maximum vibration. Those are called antinodes. So let's watch this little video about standing waves.
A standing wave is a wave pattern that appears to be stationary. The pattern is caused by two wave phenomena, reflection and interference. Wave reflection is caused by a wave encountering a barrier it cannot pass through. When the wave strikes the barrier, it is reflected back and is turned upside down. That is, it is inverted. Wave interference is caused by two or more waves acting on the same particles. Because each wave acts on the particles independently, their effects add together. In a standing wave, the wavelength and the distance over which the wave travels to a reflective barrier are related. For example, a standing wave is formed in this rope when the rope is vibrated with a frequency that produces a wavelength that is 2/3 the length of